Okay, I don't know what happened. I think my broadcasting software crashed or something. Something hiccuped. That definitely wasn't YouTube in this instance. At least I don't think so. But I do need to give everybody a chance to come back in here. And then what I need to do is I need to be up now. So we'll type that. And hopefully everybody that was there sees that, because then I get rid of this. And we put this one in its place. Yeah, I don't honestly know what happened for that. That was bizarre. All right, I do need to give like a few seconds for everybody to come back in. Let me post in the Discord channel also. Let's see here. New stream is now online. Go back to the main YouTube page, and it should be there. Okay. Cool. Sorry about that. I apologize. Technical issues abound. Okay, so I got that going. I need to go back to this. Do not pause this page. And there we go. Okay. How many people are back in here? Okay, I have about 11, so hopefully most people will find their way back here. If not, they'll just have to catch the VOD afterward, I guess. Okay, so we're going to continue. We were just discussing how the number of marks affects your measurement, and that if you have more marks, you can get a better measurement. And if you have a better measurement, you could write down more numbers. So you could see that the 4.5 we wrote on the ruler on the left is kind of a rough approximation, but 4.56 tells us more information. Now, that last digit that you write down is always going to be a little bit uncertain. The uncertainty is always implied by the last digit. So, for instance, if my balance that I am weighing stuff on reports these numbers, 0.259, 0.260, 0.261, 0.260, 0.259, it bounces between those, then the error that we are observing here is in the last digit. Where is my cursor? There's my cursor. Or in other words, the thousandths place. So what that means is that if I were to write down a number, I would write down the average, and I would say plus or minus 1 in that thousandths place. Now, in this class, we're going to ignore writing the plus or minus 1. We're going to just have it implied that plus or minus in the last position is 1. So, again, this last digit over here this will be implied. That any number that you see in this class, the very last digit that you write down, will have some degree of error associated with it, and that any value plus or minus 1 in that position is acceptable. All right, so now I have a few sample questions to just sort of summarize what we're doing, and it also give us a second for people to come back in here. I just want to make sure I get everything on the screen. Let's suppose that you are weighing a sample and you don't push tare, and the mass of the little weighing boat that you're using is 3 grams. And the masses of solid that this student gets are these numbers. What type of error did this student commit, and then how would their results be affected? Like, how would this affect their accuracy or their precision? And then finally, if two students report these numbers, what type of error was made here, and how will their results be affected by it? Now, some errors may be unaffected because when you average it, they'll go away, and other errors will persist. So be mindful of that in your answer. Type in what you think the results are in the chat, also just so that I know that you are here. And I'll come back to you in about 2 or 3 minutes, and we'll talk a little bit more about numbers before we call it a day. One more minute, we'll go over the answers together. All right, I'm back. Sorry about that. I was just checking to make sure that I didn't get another email from YouTube saying, "Oh, your channel has been banned because we hate you. We hate education." I probably shouldn't be saying that on their platform, but whatever. Right? All right, let's look at number 1 here. All right, so I've noted that this student has forgotten to hit tear, and as a result, if the weighing boat weighs 3 grams, then the masses of solid that these are going to include that error. So not only do I have the solid in here, I also have the mass of the weighing boat. So all of these numbers will be too large by the same amount that the weighing boat weighs. So what type of error is this? Well, this is an error of procedure. And so the error type is systematic. My C didn't appear for some reason. And then how will the students' results be affected by this? So their precision will be fine, because if they did everything else correctly, then their results will be precise enough. But their accuracy is off and is in the positive direction by a lot. They're going to have a very large percent error. All right, for number 2, I'm going to change my text color here because I'm getting tired of this green. So if this is the measurement that one student reports, and this is the measurement that the other student reports, their measurements are very, very close to each other, and they looked at it correctly. So they didn't commit a systematic error. The only deviation is just in their perception. And that could come from any number of things. That could come from maybe the water is fluctuating or is stuck to one side of the container slightly more than the other. Or maybe there was just something in your eyes and you blinked and got that number. It's hard to say. Could be any source. That's why it's a random error. Now, how will the student's results be affected by this? This will affect the precision, but only very slightly. Not slightly, slightly. And this will have virtually no impact on their accuracy. Because, again, we can average it out. So, accuracy is fine. And we're all set. All right, if you have any questions, let me know. I'm just looking at something real quick in my notes. How many slides do I have for this next section? I think I want to start with this section tomorrow rather than end on it and then have everybody forget about it, because it'll make a good segue for the next part, which is math. And then after that, scientific notation. So that'll be good. This is a good stopping point. We'll stop a little bit early, which is kind of obnoxious because now I have a 10-minute lecture video after everybody just got back here. But I think that we've covered all of what we really need to today. So we talked about precision and accuracy. My recommendation for looking at the online reading is that you make sure to go over those terms and make sure you understand them. The reading that links to the OpenStax textbook has a few more examples in there. And then I'm going to use problems very similar to those that are on the worksheet for the quiz, which will open next week. Not this week, because we haven't finished Unit 2 yet. So on Monday, when we come to lecture, so we'll have lecture Monday and Tuesday next week. On Monday, we're going to finish Unit 2, and then the assignment will open up for the first quiz. And when we're done talking about Unit 2, we'll start talking about the lab, The first lab is a very simple activity for you to just practice making observations in the lab on a video. But until then, I think we'll just leave it at that. So let me go to this screen here. I do want to thank everybody for coming to the lecture. I apologize for all the technical difficulties. I'm sure that will happen again at some point. If the video crashes at any time, please spam the chat like you did, because I didn't even notice until I saw, hey, the video isn't loading. And I was like, oh, I wonder if there's an O. And then I noticed it said dropped frames all. So that's good that somebody caught that, and hopefully you didn't miss too much. You can go back and look at the VOD if you need to. Those should be posted after the class. I'll put them in the playlist. But yeah, that's really all I have. Have a wonderful weekend, and I will see you again next week for week number 2 and more tinkering with numbers. Take care and have a good weekend.